When we say system, we mean we have two or more equations with two or more variables. Again, our solutions are going to be where they intersect. As we talked about some time ago, we have four possibilities. Remember chapter 2? What are these lines called? They're called parallel. How many solutions? No solutions. They don't cross, right? How about this one? This is perpendicular. You have one solution. This one, this is the same line. We have infinite solutions. And then we have this one. And the other. You have one solution. And what we did this earlier is here, the slopes were the same, but the y-intercepts were different. Here, the slopes are the same, and so were the y-intercepts. That's why it's the same line. Here, the slopes are negative reciprocals of them. And this is just the slopes are different.
Why does it not matter for the last one?
Nope, because you could have the intercept could be at the where they solve. So if you have different slopes, you know they're going to cross at least one place. Now, if you have no solutions, inconsistent means you have no solutions. So consistent means you have one or more solutions. Because remember, is one the only way you can cross these lines? No, you can have infinite solutions. So you can have one or more solutions. Then we have look at the concepts of dependent versus independent. Dependent means you can algebraically modify one equation to become the other equation. They're the same thing. They're the same equation. It's just that they have a constant multiple different of each other. Independent means they're independent. They're themselves. So independent means you cannot make the equations the same. So for example, parallel lines, are they consistent or inconsistent? Inconsistent, dependent or independent? They're independent, but we can The only thing difference about them is their y-intercepts are different. So because of that, you can't make them one or the other. How about same lines? They're consistent because you have more than one solution. Can you make one line look like the other? Yeah. So it's dependent.
They're already.
Yeah, but for example, if we had x plus y equals 4 as opposed to x plus 2y equals 8. That's what I'm saying. I could divide all of them. So their graphs are the same, but their equations, the way they look like, are different. All right, so let's look at these. I want to try to finish this up before we have to leave. Three methods to solve systems. We have graphing, or just plot the two graphs on top of each other. Substitution and elimination. Y'all remember these? So I really don't have to spend much time going over these. Good. Because let's look at this example. 2x plus y equals 2, x minus y equals 7. Graphing is just a boring one. It's solve for y, plot the points, and you're done. So we're not going to do that. Substitution. For this equation, what are the procedures? Right. Well, choose one equation and solve for either variable. It doesn't matter. It doesn't have to be x. It can be any, whatever's easiest for you. So out of these, this is line 1, this is line 2. Which line looks easier to deal with? Line 2. So I'm using line 2. X minus y equals 7. Which variable am I going to solve for? Okay, if we solve for y, then we move the x over. We have negative y equals negative x plus 7. Change the signs. Y equals positive x minus 7. We'll come back to that one to find the y value. So second step.
Substitute the x minus 7 for every y in the other.
Yep. Plug that equation into the other line. You're substituting, right? So since I used line 2, the first one, I gotta use line 1 in this one. So I have 2x plus y equals 2. Anywhere I see a y, I put an x minus 7 in it. I substitute that in there. That's what y equals. So I have 2x, I don't need the parentheses. Combine like terms, 3x minus 7 equals 2. 3x. So that's the x component of my intercept. That's the x. What do I find the y? I plug that one back in the first step. So y is equal to x minus 7. 3 minus 7 is negative 4. So my solution is 3, negative 4. That's substitution. Solve one equation for a variable, plug it in the other one, solve for the variable, plug it back in the first. Now, elimination. Elimination is a little bit more fun. So we have 2x plus y equals 2. X minus y equals 7. Elimination. Here you choose a variable to eliminate. when we add the lines together. The condition is this. Same coefficient. Opposite signs. Yeah, so in this case, let's do X because Y is gonna be too easy. So if I'm gonna get rid of X, they have to have what number in front? They both have to have a 2, one of them has to be negative. So I take this second line, since it's a 1, I multiply it by -2. So I get -2x, -2, -y is a +2y equals -14. Make sure you distribute to everybody. Add the two lines together. The x's cancel. 2y plus y is 3y. -14 plus 2 is -12. So y equals -4. Add the two lines together. Solve for the remaining variable. Now, since we used both equations in the first time, it doesn't matter which equation you plug it into. Plug that value into either of the original equations to find the other variable. So I'll plug this one into x minus y equals 7. Anywhere I see a y, I put a -4, so it's x minus -4. So it's x plus 4 equals 7. Subtract 4. X equals 3. So my solution is 3, -4. Yeah, but you don't want to. You check it by plugging these numbers into the answer in the questions to see if they're both equal. Okay, there are conditions here. Situations can happen. If when you finish doing everything, you get 0 equals 0, or a number equals 0. If you end up with 0 equals 0, all the variables disappear, equals, then it's infinite solutions. Any values work. So they're the same line. They're dependent. If you get a number, if they're not equal, then we have no solutions. They're independent. Nothing will work. So that's after you do everything. If the very last step, if everything cancels out, it's perfect, then it's, it's the same answer, same question. But if they don't, so that's graphing substitution elimination. There's another method that we use in mathematics a lot